All right, week three, Wednesday, chapter 5. Are we reading the textbook? Okay, that's good. That's good. And is that going okay? Reading the textbook. All right. The extended examples, like they're long and it's easy to kind of just skim over it, but there's actually some really good code written in there, and so I encourage you to kind of take the time to do that. You can even, if you're looking at the online textbook, and I assume almost all of you are, rather than the physical one, you can even just, there's a little button in the corner of each kind of code block. So let me just pull it up. So modern data science with R. All right, so as soon as it loads. Okay, so each of these things we have, it says extended example, and at least on my computer, if you hover over the right-hand corner, this little copy to clipboard shows up, and then you can come over to R, and you can kind of paste it in there into a script or a new markdown document, and so I'm gonna I can just kind of paste it. I can run. Whoops! I guess I have to install. So you can kind of run through a lot of this code. So now sometimes I think I saw on Campus Wire they've changed the name of one of these tables from master to people or something like that. So you might have to make some small modifications into your code when you copy and paste it. It may or may not work directly as it appears, but you can. So anytime you get this error, could not find function this, all right, just load tidyverse, okay? Tidyverse will load kind of all of the libraries that you need. So it'll load dplyr, ggplot, the function that has the little pipe, okay? All right, so now I run that. We've made the METs, we've made the METs for the years 2004 to 2012, and we can kind of take a look at that. And we've got my METs, which is, if you read through this, one of the authors worked with the New York Mets, during a period of his career, and so these were, this is how the data kind of went there. Okay. So I'm having trouble logging over here. Let me see what's going on over here. Okay. So anyway, that's one encouragement. I know you're also juggling a whole bunch of other responsibilities and stuff, but one thing to kind of make, I think, your time reading the textbook effective is to, copy and paste, okay, work through some of these things, and then actually even better, sometimes, if you can do it, is rather than doing copy and paste, just retyping everything, all right? And this will establish some good habits, right? So here I'm going to just retype this thing, select filter, teams, team ID equals New York, NYN, is that the, yeah, that's the Mets, and, right? And what this will also establish, okay, is it will, because coding is one of those things where if you don't do things like perfectly, right, if you don't get the commas in the right place, if you don't get the parentheses, closing parentheses in the right place and things like that, like your stuff breaks, right? And so by typing things exactly as you see them, and I guess I didn't make the so see, I encountered an error, which means I typed something in wrong, right? Oh, teams, TMS, right? And so now it works, okay? And so it's one of those things where just an important skill is being able to read code, and part of being able to read code is the noticing every single character, right? And it doesn't work that way when you read books. When you read books, I don't know, have you seen like these things going around on the internet where they purposely have scrambled all the letters and the words, but you're still able to read it? Okay, that's how your brain is accustomed to reading words and books and sentences, and that's why you can have kind of these errors in there, but it works just like you're able to communicate. Okay, computer code doesn't work that way. Part of reading computer code is you have to kind of change the way you read lines of text. Is you have to go, okay, select, and then you pay attention to, where the commas are, where the parentheses are, where each of these things go, because changing one of those things can mess things up, right? And so sometimes, just to kind of develop that particular skill, I will, and I still do this sometimes myself, is rather than copying and pasting, copying and pasting is so nice because it's going to copy it exactly and it's going to paste exactly. But just to kind of develop this own kind of skill, sometimes I just retype code directly myself, right? And that also helps me because a lot of times I have to type code in real life in terms of like, as far as a classroom demonstration goes, and it's embarrassing when you get it all wrong and stuff. And so by kind of typing it establishes, I don't know, muscle memory is not quite the right word, but I guess the internal vocabulary where you understand how these things pop up.
Quick question.
Yeah.
What's the difference between console and terminal?
So the console is you interacting with R, and the terminal is you interacting with your kind of computer system here. So if you're familiar with Bash or the command prompt, so on Windows, this is the command prompt, and this is where I would do things like change directory, and I've got a directory called stats21. So this is interacting with the computer in the terminal, and the console is interacting with R. If you have something like Git installed and you're going to interact with GitHub, you'd probably do that from within the terminal. I actually don't know. Let me see. Yeah, so here I have Git installed on my thing, and I can interact with Git from here. But anyway, that's the difference between console and terminal. Okay, what I wanted to talk about today is working with multiple tables, and so I'm going along into chapter 5, and I'm going to be bouncing a tiny bit back and forth between graphics and data wrangling with one table, and then today we'll look at chapter 5, and then we'll also look at chapter 6, tidy data, and we'll kind of bounce around a little bit. I want to introduce your kind of final project either on Friday or next week, and part of that discussion will involve kind of looking at some graphics that groups have produced, that some were good and some were bad, and I want to kind of give you some cases of things to to think about when you're establishing a graphic, right? So okay, but let's talk about these two table verbs. So we're working in the tidyverse. One of the things within the tidyverse is dplyr, and so dplyr is the kind of set of the package that has those functions, select, which selects your columns, filter, which filters out rows, things like mutate to create new columns, group by and summarize, and kind of all of those other things, arrange, and there's a few more, but those are kind of your big ones. You also have these functions that will allow you to combine tables. So sometimes you have one table over here and you have another table, and you want to kind of combine this information. So maybe you have a table of customer information that includes maybe their email address and their phone number and stuff like that. And then maybe you have a table of payment information, okay? because some customers, right, if you're running some web store, some customers might have multiple payment forms saved, right? They'll say like, oh, this is my PayPal information, and this is my I don't know, credit card, Visa credit card, this is my MasterCard, this is my, I don't know, what else can you pay with? You can pay with like Amazon or something, right? Sometimes you say check out with Amazon, and so you might want to have like those things at least their IDs ready. And so so how do you do that, right? How do you kind of combine that information? So we do what we call joins, table joins. There's a whole bunch of stuff, okay? And you can read more this article on two table verbs. And so we have filtering joins and some other things, but we're going to kind of be looking at kind of mutating joins. I don't know if you guys are familiar with SQL or SQL. They have a join operation, and this works in a similar fashion. And so if you're not familiar with SQL or SQL and you want to kind of learn, well, this will kind of at least give you an introduction to some of these concepts of joining tables, because they work very similarly. And so even though this class is not focused on teaching SQL, I know a lot of you are like, anytime you look for a job, it's going to be like, you need to know this kind of stuff, right? SQL and Python, yeah. And so, but SQL is one of those things where I think you can teach yourself. I don't know if it's necessary to have a 10-week course devoted to SQL. Well, okay, this is a side note. If you say, like, I want to learn SQL, there's a whole bunch of stuff on the internet, and I want to kind of just upfront say there's two very different kind of paths that you can take in SQL. One is establishing SQL as a database administrator, and you're going to create a database system, create a schema, and do all of that. That is very complicated, and you will probably need like multiple courses on that. The other part of SQL is just writing queries to get the information, extract the information, right? It's the difference between creating Google search and using Google search, okay? Using Google search is pretty easy, and they've actually made it a lot better. I mean, not better, but just like even easier. I would say being able to search Google is still kind of a skill, right? Like being able to find the correct thing on your search engine. And sometimes you're talking to someone, you just say, "Oh, look it up on Google," and then you watch what they type into the Google search, and you're just like, it's like making you cringe a little bit because you feel like, oh, that's not going to be an effective search, right? So being able to use Google effectively and being able to search it is still a skill, but that's like relatively quick and easy to learn versus like creating Google. That's like really hard, okay? So, and I would say it's not as extreme, but kind of like that. Creating a database, administering a database, hard and complicated, but being able to write queries to extract information from a database using SQL is a lot easier. And most places, when they're looking for somebody who's, quote, capable in SQL, they're looking for somebody who knows how to write these searches, not how to set up the entire database. So when you read things, when you search for, like, I want to learn SQL, you don't have to learn this creation, just like how do you write queries.
Would DataCamp be a good resource?
Yeah, DataCamp would be a good resource for there. All right, anyway, can we read this? What is this gonna create?
Vectors. 2 vectors.
It's wrapped inside this function tibble, which basically creates a data frame. So what is the resulting structure? People is going to be what? It's going to be a tibble, but how many rows, how many columns? What do we have?
2 columns and 4 rows.
2 rows, 2 columns, 4 rows. 4 rows and 2 columns, okay? What about states? What do we have here? 3 rows, 2 columns, yeah, okay. So this is what we have. So if we do people table, it's going to look something like this: 4 rows, 2 columns. States table, 2 rows, 3 columns. 3 rows, 2 columns, okay? And what do we have? We have name, and we have Adam from California, Betty from California, Carl from New York, and Doug from, well, okay, it's not, it just says CA, CA, NY, and TX, okay? Over here for the states table, I have the abbreviation CA corresponds to California, NY corresponds to New York, WA corresponds to Washington. Okay, so the first thing we're going to look at will be the left join. The left join takes whatever table you have on the left, all right, and it's going to take the table on the right, and it's going to find any matches, and it's going to add that information, and if it doesn't, it puts in an NA. So here it's going to say, so here, the left join, there's a couple ways you could write this. So let me go to the previous page and just, actually, I have it over here. So let me go ahead and do this. All right, so I have people right here. I have states. And I could do left join people and states, okay? Like this. So I could do left join people states. Here, and on this slide, I wrote people pipe into left join states, okay? So I could do left join people comma states, or people piped into left join and then states. So the one that comes first is the left table. And here I have, over here I have the column state, and I want to say when you try to look up information in the other table, match up the state column with the abbreviation column, okay? Now if they have the same names, like if this was called abbreviation and this is called abbreviation, then it would match up automatically, right? So if the columns already have the same names, it'll match up automatically. But here they don't, so I have to kind of provide this extra argument that says, you know, how are you going to match up the data? Well, you're going to match it up by matching the state column with the abbreviation column. Give it the name on the left. On the left table, we have the state column. On the right table, we have the abbreviation column. So over here, if I just do left people, so if I do this and I don't specify how to match it, it says, it gives you an error. It says, by must be supply when X and Y have no common variables, right? So here, because the state and we don't have names with the columns with the same name, we have to do this. So here I'm going to do by, and I'm going to do the state column is equal to the abbreviation column, right? And then when we do that, now it works, okay? And so here we get CA matched with California, CA matched with California, and NY matched with New York, and TX didn't find a match, so we get a missing, okay? And so anytime you have kind of duplicates, so here I have CA twice, it's going to pull up the same information. It's going to kind of repeat that information. Okay. Is that kind of...
So left join always makes a new table? I mean, new column?
Yes. Left join will basically take your currently existing table on the left, and then it's going to add any columns that exist over here. So let me add a column to states. All right, so now I let's say let's do population. All right, let's look up population of California. What, 39.2 million? I don't know. 39. What is this? 39.35. Okay.
How do you have that number?
Yeah. Well. Okay. Population of New York.
Dodge my question.
Not. No. Population of New York State. 19.5 million. And population of Washington State. 7.52. Okay. 7.51. All right, so we'll do this, right? So here, if I have this, now my states table looks like this, okay? And if I do the same kind of command where I'm going to left join people and states, it's going to take everything in the states column and tack it on to the left table, okay? And so here, it basically, all the columns in this thing, it finds the matches and then it tacks them on, right? So if I had even more information about the states, I don't know what we would want to put in, like, I'm having too much fun here. All right, capital, what, Sacramento, Albany, and what, Olympia, is that right? Somebody can confirm. So anyway, that would be the left join, and we would do that. We would do people left join with that, and it kind of matches all of these things up, right? So yeah, if you run it inside, here, it will kind of put the results in your R markdown right here. You could also.
You've just been adding more columns to the states.
Yeah, I've just been adding more columns to the states table. If I wanted to, I could add more columns to the people table. What do we want to do? Age. And we're going to just pretend, okay, Adam is what? 20, and Betty is 30, and Carl is 18, and Doug is, I don't know, 27. Okay. All right, so we've got people, we've got states, and we're going to left join. Left underscore join, people, states. And again, if I leave it like this, it says it doesn't know how to do it, so you got to establish. Unless they have the same names, then we say state on the left matches abbreviation on the right.
It runs an error because none of the columns line up. Right?
Yeah, because none of the columns line up.
Column names, right?
None of the column names. Right. Okay. And now if I changed this from state to abbreviation, then it will line up. Okay. And I could just do left join people and states. Okay. All right. Because what I've done here is this column abbreviation matches this column abbreviation. Okay. So if you do have common column names, it will match those and do that. Okay.
And Texas is never going to have a pattern.
Well, I intentionally created a mismatch here so you could see how the thing goes. Okay. So because Texas was not included in my states table, it doesn't find matches. Okay. Now I could add Texas, right? I could add Texas and then it will find a match and it will do it. All right. So that's the left join. What if I do a right join? What will happen if I do a right join?
Would it just be the opposite?
What's the opposite? What do you mean by the opposite?
Same, it takes a right table.
So how many rows are we going to have?
There's only three rows.
It depends if you do right join states people or right join people states.
Okay. So let's do right join people states. All right, well, let's see what happens. Okay, so this is what we get, all right? So I did people right join with states. People right join with states. Now what has happened? So what do we see? We have a total of 4 rows, okay? People has 4 rows. We've right joined it with everything with from this states table, okay? And here, because we said right join, it's going to keep all the rows. It's going to keep all of the rows in the right table, okay, and matches them with matches in the left. And if we have multiple matches on the left, it's going to duplicate those, right? So basically, it started off. You imagine starting off with the right side table: California, New York, Washington, okay, and it just starts off with CA, California, NY, New York, WA, Washington. And we want to find matches with these things in the left table, okay? And And so for California, it says it finds 2 matches and says, oh, well, we better include both of these. So we get Adam from California and Betty from California. We look at New York and we get Carl from New York. We look at Washington, we don't see any match. So there's no name match here for Washington. Okay. What happened to Doug from Texas? Gone, right? Never showed up because there's nothing over here that ever asked, what about Texas? Okay, because we look at the states table. Like similarly, what happened to Washington on the previous table? When we looked at the left join, like Washington wasn't even, like that information didn't even matter, okay? Because there's nobody on the people table from Washington, so why would we include any information about Washington, okay? Over here, it's like, it's a little bit weird, but it's like, oh, do we have any people from, or, you know, is there any place where we need to look up someone from Texas? And the answer is no. Yeah.
So you could get the same thing using right and left, just like switch to the table order.
Yeah. So, right. So let me.
How are the table orders like defined? How do you know which one's on the right and which one's on the left?
The one that's on the left is the one that's on the left, and the one that's on the right is the one that's
like,
on the right.
Are they always just going to be in that position, or is it like up or down?
So yeah, okay. So here, let's.
It's based on how you type it.
Yeah, it's based on the order in which you type. The table name you type first is the left. The table name you type second is the right. Yeah.
So essentially, if you do right join states people, is that the same as doing left join people states?
It's very similar, but the orders of columns will be different.
Oh.
Okay. So here, did I do that? Let's show. Okay. So we said left join.
Can we have the view quiz answer?
Oh yeah, thank you. Okay. All right. So let's do left join people states, and I think I matched the table names so that abbreviation matches. Okay. So here I'm going to just do left join people states, and it does Adam, Betty, Carl, Doug, abbreviation age, state, population, capital. And we want to know, all right, is that the same as right join states people, right? So this says keep all the rows on the right side, match them with things on the left, okay? So if you look at the rows, indeed, Adam, Betty, Carl, Doug, okay? But what is the order? All right, the order of columns ends up being different. So you get the same rows, the same information, it's just the order of the columns is different. So here, it starts with the states table, okay? And then it tacks on anything that matches from the people table. Right? So yes, left join people states and right join states people will give you the same rows, just the columns are out of order here. Okay. All right, give me a second here and let me look up your view quiz answers. I keep getting kicked out. What is going on? All right, Canvas, log in. Approve. Stats 15. Week 3 Wednesday. Okay, your first answer for today is the letter D. D as in dog. D as in dog. Yeah, question.
Just want to confirm, basically, like with the two join functions, like whichever like table you're using first, like it just adds another column that's all the matched information from the other table. Granted, if you specify like which two columns you want to match for each data set.
Yeah, so so ideally, everything kind of has a unique match, and then it will put that information there. Okay. Here, let me do a few more, and then I'll show you some other things. Okay. But yeah, it's basically going to just take information from the other table and add those columns. Right. So yeah, if for whatever reason you were kind of going through it and you were like, what state is where's Adam from? Adam's from California, and I really need to know the population and capital of California and stuff, right? Then you can kind of get this, right? You can get this information. Okay, inner join. Inner join is like the intersection, and it's only going to find where things overlap. So it'll just find California and New York matches. So Doug is thrown away, and Washington is thrown away. Okay. Yes.
So can we merge one and one variable?
Yes, you can. Let me see if I've got examples of that, and if not, we'll make some examples. Yes, you can match on more than one variable. And then the full join is like the union, okay? And so it's going to keep all the rows from both. So here we have Doug. Doug is included, and it says, oh, I couldn't find matches in the state table. And then Washington is included, and it says, oh, I couldn't find any matches in the people table. So those also show up here. So that's the full join. So that's the kind of the union. All right. So how do you get these things? So in all of these kind of examples, we've been doing by, and then we're saying the state column matches the abbreviation, or I kind of gave it things. And so if you don't specify anything, then dplyr is going to use all the variables that have the same name in both tables, right? And so you can leave this blank, and I've done that over here with states and people. But in general, it's always good to write this out, to write out the by, and do kind of, even if it's like by abbreviation equals abbreviation. That's going to help you read your code and understand how things are matched up, right? So when you're reading your own code later, you don't have to also remember exactly how these tables are formatted and structured, okay? You can just do by equals x, and so you don't have to do by abbreviation equals abbreviation. You can just do by equals abbreviation, and that will assume that the abbreviation column exists in both things. Okay. So, all right. So I have this example. Okay. And here I have Adam, Betty, Carl, and Doug, so the same people. And then the abbreviation, like this would be a terrible thing to do, right? So we have places, and then CA, does CA refer to California or Canada, right? And so what if we have that, okay? So what is if I do a join here, a left join, what am I gonna get?
CA going to be California, the second CA in Canada.
So we're going to get like a bunch of kind of duplicate rows. We're going to get Adam CA matched with California, Adam CA matched with Canada, and then Betty also has CA, so we get Betty CA California, Betty CA Canada, okay? And then we have Carl NY, there's only one match, so we have New York, Doug from Texas or TX, there's no match there, so there's a NA, okay? And so now Adam shows up twice and Betty shows up twice in my table. And this is probably not what we desired, okay? Maybe this is exactly what we wanted, but a lot of times you don't want something like this. But you could also imagine if you had like kind of more than one duplicate row, right? And so if I had let me scroll down here. So if I threw in another thing, right? What else could be a CA? Cambodia. Okay. All right. So we have that, and we have that, and then if I do a left join here, people and places. Okay. of course, by equals state equals abbreviation. And if I do that, so now Adam is in triplicate, okay? And I think, like, if I just accidentally have a duplicate row here, right? So if I have CA and California again, okay, so now all of them, California, Canada, Cambodia, California again, right? So this is, so if you're gonna try to do some kind of matching thing, you really kind of want to make sure that whatever column you're using for the match is gonna be pretty unique, right? You don't want to have stuff, right? And so you have to kind of think of, like, you know, how is so you have to be careful, right? So if you said, okay, you know, school abbreviation, right? So I don't know, when you had to, like, when you took your SATs and you had to say, like, send my scores to these schools, and you put in a thing, you know, if that database wasn't pristine, it's gonna get all messed up, right? And then you could say, okay, well, you know, code, you know, 7654, that is UCLA, and then somebody else might be like, oh, University of California, Los Angeles, and somebody might be like UC Los Angeles, and somebody might do U.C.L.A. And then it's a mess, right? So you want to kind of have one entry for this, right? So non-unique matches. Something similar if we do the right join, okay? Now it says, you know, California got matched with CA gets matched with Adam and Betty, and then all of this stuff here. Okay. This this is also a difference between the left join and the right join. Okay, so people left join places. We said, is that going to be the same thing as places right join people? Okay. So here this time I have to write abbreviation equals state, because I've swapped the order of these things. Okay, so one thing that happens when you do people left join places and places right join people, a key difference here is that the row order is also determined by the tables, right? So in the places table, it goes CA, New York, CA, NY, WA, CA, CA, CA. And so the matches go also in that order. The CA, California, New York, CA, Canada, and then Adam, Betty, Cambodia, Adam, Betty, California, again, Adam, Betty, like this. Versus over with the left join, you know, the order of the names were Adam, Betty, Carl, Doug. And so it goes Adam with California, Canada, Cambodia, California, and something like that. So in both cases, we end up getting 10 rows, and it's the same information, but the order is going to be presented differently. So that's also another difference between left join AB and right join BA. They give similar results, but the ordering of the columns and the ordering of the rows will be different. Okay, let's, is it already 9:45? Oh my gosh, okay. Let me just give you your last two view quiz answers. They are A and B. A as in apple and B as in bear. A as in apple and B as in bear. Our view quiz answers 2 and 3. Okay, so here is a table. This table is called NYC Flights 2013, or I'm sorry, NYC Flights 13, and I think it has, I don't know about all, but there's like 3 major airports in the New York area: JFK Airport, LaGuardia, and Newark, I think. And here it looks at like kind of all of these flights. I think departing, exiting the New York area, and over 2013. And so there's a lot. 336,776 flights, and there's a whole bunch of columns, right? So the year, the month, the day, the departure time. Unfortunately, the departure time is formatted all funny, okay? So it says integer, but it's not this, right? So this is like 5:54 in the morning, and this is 6 in the morning, and this is 5:58 in the morning, and something like that. What's the difference between 5:54 in the morning and 6 in the morning? How many minutes difference? 6 minutes, right? But if you treat these as integers, this is going to come out with a difference of 46, right? So you can't just subtract these values and say like, oh, you know, how many minutes delayed were we, or something like that. So it requires some kind of finesse, you know, working with that and stuff. And there's this column that says, you know, how much of a delay, right? So the scheduled departure time was 6 o'clock and it took off at 5:54. So it actually took off early. So the departure delay is -6 minutes. Here it was scheduled to depart at 5:29 and it left at 5:33 in the morning. That sounds pretty miserable, taking off at 5:29 in the morning at the airport. It's like, what time do you have to get at the airport? Like 3 in the morning? So you're like 2 hours before your flight, because that's what you're supposed to do, right? And if it's like your dad's taking you, you're like, oh, we're going to get there like 7 in the afternoon or 7 in the evening the day before, because we don't want to be late. And like every year I'm like turning more into that person. Okay. But anyway, there's this one column, carrier, okay? And carrier is like, which airline was it? So UA, any guesses? United Airlines, AA, American Airlines, B6. What's that, right? I don't know. Okay, DL for Delta. Okay, and so you have all of these things, and you're like, what's B6? So this is where having a second table, and so we have one table called airlines, and this B6 is JetBlue. Okay.
Why is it not JP?
I don't know. I don't come up with these airline codes. All right. So this is, I think I don't know what did they and well, this is from 2013. So like, airlines is like a weird thing, and like airlines like go out of business like every day, right? It's like, oh, take flights to Iceland for like $600, and then like 1 year later, that their airline's gone. And it's like, oh yeah, we couldn't afford flights to Iceland for $600, and it's like oil prices go up. Oh, the airline's out of business. Huh? What was such a terrible airline? Frontier.
They make you sit in plastic chairs equivalent to this.
Yeah, you know, it's kind of like taking the bus. Except it flies.
So flying cars.
With a much better maintenance. Okay, and then here's another one, right? Airports. So okay. Oh, the airports are I didn't fit them on here, but you know the airports show up with all of these weird codes, right? Like you know you're flying into airport 06N. I don't know what that is. Randall Airport? Who knows what? Okay. But, you know, there's a whole bunch of these things. Apparently, 1,400 airports, and these are the locations of a bunch of these things. But anyway, you know, how do we match things up? Okay? So we can say, all right, match the carrier with the carrier over here on the left joint for airlines. And then now we can read our table a little bit easier. And so we can say, oh, okay, this was flight JetBlue, whatever, and ExpressJet, which no longer exists, and stuff. And so we can kind of read these flights a little bit easier. Yeah.
So for doing the by equals carrier, you still do that even though they have
You don't need to do that. You can just do by carrier, and then I think because this airlines table was so simple, and there's really just one column that would have matched, which was carrier, you can also leave it blank. But I recommend leaving in something in the by section here. Okay. Here I can do a summarize. Okay. So here, let's see if we can read this. We started off with flights. I'm going to group by carrier in the flights table, which is just this 2-digit code here. So we're going to group by that. And then I'm going to count them, count how many United Airlines flights, JetBlue flights, ExpressJet flights, so on and so forth. We're going to arrange them in descending order, so the one with the most flights shows up on top. And then, in order to kind of be able to read it a little bit easier, I'm going to left join to the airlines table, which includes the full name of the airline. So now we can see, so this is what it originally summarized. It said UA and B6 and EV and DL and AA and MQ and so on and so forth. And now I can at least read this a little bit easier and say, oh, okay, you know what? You know, Southwest Airlines and Virgin Airway, Virgin America, and AirTran and all sorts of stuff. I wrote, so prior to this is before the thing, and we did that. You can do multiple tables, and I'm out of time here, but I could join. So here, some of the columns is the carrier and the destination, and I could say, you know what, I want to look up what is the name of this carrier, and I want to look up what is the name of this airport, right? So I'm going to take flights. I'm going to left join it to carrier. What's the result of this? The result of flights left join with airlines will be basically a table with all the flight columns, plus now a new column that has the airline carrier name. And then I'm going to take that resulting table and left join it with the airports table. All right, and the airports table is going to do that. Now, because already after this operation, there's a column called name. And then after this operation, there's going to be another column called name. dplyr automatically just appends a .x and a .y. So all of the column names are still unique.
How do you rename those columns?
You can always rename them later using the rename function, kind of like mutate.
Okay.
Yeah. Okay, well, I'm out of time, so we'll end here, and we'll see you Friday.